So which of the following is not true for a rotating object at constant speed? Rotating
Evet.
object, constant speed. So constant speed, omega constant, which
Omega
means
constant.
alpha 0. Angular acceleration 0.
Evet.
So if angular acceleration is 0, net torque 0, must be 0 because they are directly proportional. Net torque is equal to I times alpha.
Yes.
If this is 0, net torque 0. This is correct. It's asking not true. Angular momentum is constant. This is the condition for conservation of angular momentum. If angular momentum is constant, in this case, net torque must be equal to 0. This is also correct.
Yes.
Angular acceleration is constant. No, angular acceleration is 0. Constant. No, it's not constant. It is 0. This is incorrect. Moment inertia constant. Moment inertia changes only by changing the shape of the object. In this question, there is nothing about that. Of course, moment inertia stays constant. So C is the answer for this question. A bicycle designer recently modified a bicycle by adding cylindrical weights to the spokes of the wheels, which will increase moment inertia. So adding weights closes to extra rotation. Now, moment inertia depends on three things. Let's remember again. One of them is adding mass. Second one is distribution of mass, yani axis of rotation, change in axis of rotation. Third one is shape, change in shape. So in here, we are adding mass. If you add mass, where you add is not important, closest or farthest, both of them will cause an increase in the moment inertia. Yani A will cause an increase, B will cause an increase. Or adding weights to the midpoint. It doesn't matter where you add. All of we did this in the problem in the it was 50 Newton in the book, 50 and 150. But I multiplied them. I made 100 and 300. Yani the way we solved at the end of section 2 is the same as this one. It's a positive net torque. Choose G. So this distance is 1. How much is this distance? 7.
8.
8 total is 8. Until G 7. 1, 2, 3, 4, 5, 6, 7. So this one produces a counterclockwise torque, positive 7 times 100, 700. This one produces a negative torque, negative 3 times 300 times 1, which is negative 300. Add them, result is positive torque. So G is correct. Yani you have to check the answer, or you will find first no rotation point. After that, you are going to check when you find no rotation point. The point on the right is going to may produce a positive net torque. On the left, produce a negative net torque. A solid sphere rolls along a horizontal surface at a constant linear speed without spin. What is the ratio of the translational kinetic energy of the sphere to its rotational kinetic energy? Kinetic energy rotational over kinetic energy total is C divided by C plus 1. So this question is not talking about that. It's the ratio of translational kinetic energy to rotational kinetic energy. So you have to find a new equation. Translational kinetic energy equation 1 over 2 mv squared.
Evet.
Rotational kinetic energy 1 over 2 I omega squared. Now I'm going to continue. 1 over 2 will simplify. mv squared. What is I equation? C mr squared. Correct? For any shape. CMR squared. Multiplied by omega squared. So these m's will simplify. These r omega squared is equal to v squared. V squared, they will simplify. It's going to be 1 over c. Yani if you want to find kinetic energy translational to kinetic energy rotational, 1 over c is the hack for this. A figure skater during her final can increase her rotation rate from initial rate 0.5 yani omega initial to final rate 3. So if her initial moment inertia what is final moment inertia? So you are going to choose the conservation of angular momentum, I initial, omega initial, I final, omega final. Initial moment inertia 4.6. Initial angular speed 0.5. Find final moment inertia, final angular speed 3. And it's so simple. You will find the answer this way. 0.77. A seesaw is 4 meters long, is balanced in the middle. A 80 kilogram person is at the far left end, and then his 60 kilogram wife is on the far left hand. So we draw a 4 meter long seesaw.
Okay.
Total length is 4 meters. And from midpoint, it is balanced, yani to one side, to other side. And 80 kilogram is at the far left end. Yani left end
So
is
we should keep it
here.
on the left.
80 kilogram person and 60 kilogram wife on the far right end.
Right.
60 kilogram wife. Where should his 20 kilogram child be placed to put the seesaw in equilibrium? Now it's at equilibrium because this distance is 2, that distance is 2. So they produce not one of them produce greater torque, which is 80 kilogram produces greater torque. So the child must be staying on the right side. Yani it must support the smaller torque. So child is going to be 20 kilogram. And it will have some distance to the fulcrum. This is the question. Find this x. And find the torque of each. This one produces a torque which is equal to 2 times 80. 2 times 80, which is going to be 160. It's positive.
Yes.
60 kilogram produces negative, which was clockwise, negative 60 times 2, which is
2.
negative 120.
20
So,
times
and
20.
this one produces negative 20x.
Negative 20x.
X, which x we will calculate. Some of them must be equal to 0. Add them and make them equal to 0 for condition of equilibrium. So 160 minus 120 minus 20x is equal to 0. So this is transfer on the right side. Here is the answer is 40. I think let me continue here. 40 is equal to 20x. As x is equal to 2 meters. Which means this child is at the position of the woman because this distance is 2 meters. And x is 2 meters. So in fact, child must be in here. Yani right where the woman is or the wife is. Only at the same location as the wife is the correct answer. So a cat pushes at outer edge of a door with a force perpendicular to door. Axis of rotation is about which point the door rotates? About hinges. Every door rotates about hinge. The line through the hinge is going to be axis of rotation. One or some of the following objects has kinetic energy about rotation. Yani rotational kinetic energy. Which one has rotational kinetic energy? Falling hospital, no, it's translational. Spinning, yes. Rolling, yes. So both B and C. How does the moment inertia of solid ball changes if mass and radius doubled?
Hocam, moment of inertia 2 over 5.
Yazacaksın. Çok zor değil bu ya. 2 over 5 mr squared.
Evet.
M doubled olursa increases by 2. Bu bir. R if doubled olursa square ama because there is 2 ama burada
Yes,
square
4.
olduğu için it's 4. 2 times 4
8.
8.
Ama hocam ben de böyle yaptım ama what about this 2 over 5? It's coefficient.
2.5 değişiyor mu? Is there a change in 2 over 5?
No.
So you are looking for
But
change.
hocam,
You are looking
can
for
I multiply
change.
this 8 by 2/5?
Nihan, we are looking for change. 2/5 is not changing. What is changing here? M and R. Question is asking about change. How does the moment inertia change? Initial 2/5, initial 2/5, final 2/5. So it doesn't change. But M initially M, finally 2M. R is initially R, finally 2R. But initially 2/5, 2/5, it doesn't change, initial and final. When a solid object rotates with a constant angular acceleration, alpha exists. If there is alpha, torque exists, absolutely. If there is alpha, there is torque. So all points on the object rotate with the same centripetal acceleration. No, centripetal acceleration, AC is equal to R times omega squared. Omegas are same for a rigid object, but R's are different for every different point. Some are close, some are far. That's why AC is going to be different. All points will have the same centripetal acceleration is not correct. Net torque applied to the object must be zero. No, if there is an acceleration, there is a net torque. C is correct answer. The net applied must be constant. This is correct answer. All points on the object rotate with the same and tangential acceleration. O da doğru değil because tangential acceleration R times alpha. Alpha are same, but R's are different for every different point. So tangential accelerations are also different. A football has 22 centimeter diameter and may be approximated as a thin spherical shell. How long does it take for football starting from rest and roll without slipping? 4.2 meter down and incline. Initial linear speed is 0. So this length, traveled length, is the length of the incline, 4.2 meter. So first find what is V final by using the hack. V final is equal to root of 2G 9.81 H. H is, this is H. H can be calculated by length of the incline times sine of the inclination angle, 30. Yani 4.2 is the hypotenuse times sine 30. It's going to 2.1. Yani height is 2.1. Divided by C plus 1, it's a football, it's a spherical shell. 2/3 is its moment inertia. Now find what is V final. After that, this distance traveled by the delta S, 1/2 V initial plus V final times delta T. You will find this. You know what delta S, you know what V initial 0, V final you will calculate. It's in here.
4.2.
How much torque will require your hip muscles to swing your leg at an angular acceleration of 2 radians per second, assuming the leg is a solid stick with mass of this length. So you are sitting on a chair, and this is your body. Let's say this is your leg. You are going to be moving it around this point. So length is equal to 1 meter. Mass is equal to 20 kilograms. So this is axis of rotation. It's similar to a road about at the end. Yeah, this is the end of the road. Moment inertia is going to be 1/3 ml squared. Maybe you remember moment inertia equation. You will see that if you rotate the road about an axis from the end, it's moment inertia equation 1/3 ml squared. So moment inertia is this multiplied by alpha will give us torque. Alpha is given 3. 1/3 m is given, which is 20. L is given, which is 1. So find torque. Solid ball first rolls up from the top of an incline without slipping. At second, ball throws vertically up freely with the same translational speed from the same point, maximum height. Now, there are two cases. One of them is rolling case. The other one is moving directly vertical. In the rolling case, we know that when an object is rolling, I will slow here. So there is going to be a hack equation for V, remember. V is equal to 2gh divided by c plus 1, correct?
Evet.
We can apply this equation in reverse way, v squared. Yani this time we will throw from the bottom of the incline, what is h? So cross product v squared c plus 1 divided by 2g is h. Yani if you roll it, h depends on v, c, and g. But if we throw it up vertically, last year you learned in the 12th grade, 11th grade, v squared is equal to 2gh only, not divided by c plus 1. In the dropped case or sliding case, c plus 1, and translational motion, there is no c plus 1. Then if we leave right h alone, it becomes v squared over 2g. Now,
2G.
v's are same, g's are same. Which h has greater number? First one or second one?
First one.
Because there is c plus.
C plus 1.
And that's why when it rolls, along the incline, its side will be this greater. Yani will be greater when it rolls up. So to open a door, a minimum amount of torque is needed. If the torque produced by the force is smaller than that amount, the door cannot be opened. According to the above statement, the smallest force exerted by the cat on the valve. Smallest force, which one is the smallest force? So all doors are opened by the same torque, minimum torque. Torque is equal to Ft sine theta. If all torques are the same, and also in this question, these are same, equal lengths. If you are looking for F to be minimum, theta must be maximum. At which situation theta is maximum?
In the A.
Yes, this situation. Yani F1. That's why F1 is minimum. They have a cylinder, their moment inertia equation 1 over 2 m1 r1 squared. Second one 1 over 2 m2 r2 squared. Two cylinders have equal moment inertias, and they are equal to each other. So what is the relation between r's? 1 over 2 will simplify. M1, capital M. R1, I don't know, we will find it. M2, 2M. R2, we don't know it. So M's will simplify. Then R1 squared is equal to 2 times of R2 squared. Get the root of both sides. Say after taking the root, R1 is equal to root 2 R2 olur. A force of magnitude 2 Newton is applied tangentially to a disk of mass 5 kilogram and radius of 4 meter during 10 seconds. What is the angular momentum of the disk after this final interval if it starts from rest? Yani, it's asking you change in angular momentum because initially it is 0, then final minus delta L. Delta is the question in here. How much is the change? Maybe you remember when I was talking about the conservation angular momentum, I said them classroom. There is an equation in the 11th grade. If a force acts on an object by some time, it causes a change in linear momentum, something like this. Rotational analog of force is torque. If torque acts some object by some time, it causes a change in angular momentum. Now, if you want to find this equation is not given in the 12th grade, but it's a very useful equation. It explains you how angular momentum changes. We need to know, apply some torque by some time. So torque can be calculated because we know how much is the force, 2 Newton. Distance is going to be radius of the disk, which is 0.1. Angle 90, because it acts tangentially, sine 91. You don't need to write this. And delta t, 10 seconds, is going to be how increasing the angular momentum. Multiply them all. It is 0.2, I think, is it? Or 2 sadece. Yeah, B. Yani there is a long way otherwise if we don't use this one. You are going to calculate how much is alpha After that, you will calculate how much is omega final. After that, you will find L is equal to I times omega final, or just one. Spinning ice skater doubles moment inertia of his body by moving his arm outward. How does the rotational kinetic energy changes? So we have an initial and final case. Initially, moment of inertia I, angular speed omega, rotational kinetic energy 1/2 I omega squared. Finally, I doubles moment inertia, yani 2I. But according to conservation of angular momentum, if angular moment of inertia doubles, angular speed must be halved. Then write kinetic energy, rotational kinetic energy 1/2 I changes to 2I. Omega changes,
And
omega 2 squared.
omega 4 over
1/2 2I times omega squared over 4, huh?
evet.
These 2 and these 4 simplified, here is 2. Yani answer is going to be these 2, let's get this 2 at the beginning of the equation. 1/2 I omega squared. What happened to rotational kinetic energy? This is rotational kinetic energy initial. This is also initial, but what happened to the in front of the equation? 1/2. Yani half. Yani this is going to be change. There was a rope. There was a 400 Newton. Here is R. We don't know how much is R. And also there are forces. One force is the weight, 315. The other one is
545.
545. It is a sample problem. At the end of the sample problem, if you check your book, there is going to be something like this. R plus tension, yani 400, is going to be greater than 545 plus 315. There is written something like this. 860, this one, yeah?
Evet.
Why don't you just calculate it correctly? 860. So it's going to be 460. R is greater than 460 Newton. Greater than
Hocam
460.
Burada böyle yapıyoruz çünkü we have component of R.
Yes, those components
X and
cancels.
RY.
Yes, these components cancel for that reason. They are not they are destroying each other, but this is the case. Yani at the end of this example, this is written. Be careful about that. Calculate the angular momentum of moon that arises orbital motion about the Earth. Orbital motion, circular motion.
Tamam.
For circular motion, object's moment inertia mr squared. In here, you are doing mistake. You see that moon is a rigid object, so then you are using general 2/5 mr squared, but we don't care shape. We care about the motion. Circular motions, moment inertia mr squared. Calculate the angular momentum. I times omega for moon. What is I? Mr squared. Omega, you can calculate omega for R because it revolves around the Earth 28 days. And omega for moon is angular displacement for one revolution, 6.28. Time for one revolution, 28 days. Every day is 24 hours. Every hour is 3,600 seconds. You will first calculate omega. Write omega in here. M is given. The moon's mass. And also distance to the Earth, yani radius of the orbit is given. This is radius. This is moon's mass. Then this is omega. You will find.
Hocam soruda söylüyor ki assume that the moon is perfect solid sphere.
Söylesin what is going to happen if it says that.
Ben moment of inertia 2/5 mr square yazdım.
Dediğim gibi, we are not caring about the object shape. We are caring about the motion. If it is rotational motion, you would use it. But it's not rotational motion. The motion of the moon around the Earth is circular motion. Moment of inertia equation for circular motion, mr squared. We don't care about the shape in this case. Just we
Every time for
care about
circular
the
motion
path. Yes, mr squared.
Tamam hocam. Hocam 19. Çok kolay
Bütün
ama
soruları bana yaptırdın ama böyle olmaz ki. Burası bak axis of rotation değiştiğini görüyorsun değil mi? This is all. Did you see it?
evet evet.
Did you do according to this axis of rotation or according to the example in the book? Which one?
Valla öyle yapmadım hocam. Tamam sonra
Ya,
öyle yapıyorum.
İşte unuttun, gördün mü? İşte gider böyle yaparsan, atlarsan, ezberlersen ondan sonra sorular böyle gelir. Hata yaparsın. Dikkatli olacaksın. Evet. Next one.
Hocam 26 ve 29 biraz logic. Onun için anlamadım.
Calculate angular, hayır logic değil. Yine bu bak. Calculate angular momentum of that arises from its spinning motion. Spinning motion işte now this time
Hayır hocam.
rotational motion of that you are going
28.
to use 2016 mi?
Evet 26.
Bunu mu yapıyoruz? 20 ha, tamam. What is the Earth's moment inertia about its own axis 2 over 5 mr squared. Now you are going to use this. L is equal to I
Tamam
times
tamam.
omega, you can find it. So
Okay.
Earth is rotating about its own axis in 24 hours. Omega is equal to delta theta over delta t. So 6.20 divided by 24 hours, hour to second, then you will find omega. After that, you will write omega in here, I in
Okay.
here, L.
Okay. Tamam hocam. Hocam 28 biraz farklıymış.
At which angle between the force and distance from the axis force required to loosen the nut that holds the wheel equals twice of its minimum value. So minimum value is going to be according to torque equation, F d sine theta. Minimum value happens when angle is maximum. Yani 90, yani 1. So if you write this equation for minimum value, torque is going to be F minimum times T.
Evet.
But this time you are going to use another force, but it's going to be twice of the minimum value, 2F minimum. Distance same, but there is going to be some angle for this. Calculate this angle. So both are equal, same torque. You make them equal. Make them equal in here. So 2
So we will
times,
halve the sine theta.
sorry?
We will halve the sine theta. It will be 30.
Evet, yani öyle devam edersen F minimum, the F minimum they will simplify. Sin theta is going to be 1 over 2, yani 0.5. Which angle has 0.5 sin theta? 30.
30. Evet.
Minimum force loosen the nut at the wheel at the angle of 30. Yani 30 degree'deyken minimum force F'miş. Torque is equal to F d sin 30. F minimum force. Question says that how would this minimum force changes? Then what is final F? Final F. Same distance, but angle this time becomes 90. Both torques are equal because to rotate object you need minimum amount of torque required. Torque, they are equal.
Both half oluyor.
F minimum times d times sin 90 is 1. No need to write it. Is going to be F d sin 30. F, these will simplify. So F minimum is going to be sin 30 0.5. Yani 1 over 2. 1 over 2 F.
Okay.
Yani
So F half oluyor.
alt.